Hello again everyone, Mr. Cruze here, this time with a video for you for a lesson since I'm not there today. Remember, I'm at the administration building, so if you happen to have any questions, you can always tweet me later or you can see me before school tomorrow. But this video is for Wednesday, November 12th, 2014. You will be given a test review to work on today, but before we get there, we need to answer an important question. What if our degrees of freedom is not on our t-table? We look at our t-table and we see our degrees of freedom goes from 1 to 30, then all of a sudden it jumps to 40, 50, 60, 80, 100, 1,000, then after that it goes to z. What happens if we get a degree of freedom that's not there, though? What are we supposed to do, right? Well, that's what we're going to figure out today. We're going to use a method called interpolation. All interpolation means is to insert, estimate, or find some sort of intermediate term in a sequence, okay? Basically, it means we're going to use a couple of values that are around what we're looking for and kind of get an estimate of what it would be. This doesn't mean it's exactly what the critical value would be from the degree of freedom, but it's a pretty close estimate, at least close enough for what we need, right? So let me try a couple here for you. Find the critical value for a significance level of 0.005 where the degree of freedom is 33. A quick scan of your table shows you that on our table we have a degree of freedom of 30 and then it jumps to 40. We don't actually have a 33, right? Let's see, what are the values there for 0.005? With a degree of freedom of 30, 0.005 gives you a critical value of 2.750. And 40 gives you 2.704. One thing you should notice about these critical values is they're decreasing, right? 2.750 is bigger than 2.704. So you'll notice if I subtract these two, if I actually subtract them, we get a difference of 0.046. Okay? Which means in 10 degrees of freedom, the critical value is decreasing by 0.046. So if I want to figure out how much it's decreasing every one, I should probably divide that by the difference between these two. So these two are 10 units apart, right? 40 minus 30 is 10, right? So 10 apart, so I'm going to divide this by 10, which means, on average, your critical value is decreasing. Critical value is decreasing by 0.0046 every degree of freedom. For every 1 degree of freedom, okay? So, off to the side then, we can do it a couple ways, right? I'm going to show you both ways. So 30 is obviously 2.750. If I want 31, I could subtract 0.046, and that would give me 2.7454. Okay? Keep subtracting. So degree of freedom 32 would be 2.7408. And one more time to get to 33 will give you 2.7362. So if I wanted a degree of freedom 33, there is my approximate critical value. So then you would say reject if t is bigger than 2.7362 or smaller, depending on if you're dealing with the negative. Okay? Another way you could do this is you could say, well, how many degrees of freedom difference is there between 30 and 33? Well, there's 3, right? If you subtract them, there's 3. So you can take 3 times this difference, right? Because you're subtracting 3 of those, basically. That'll be, what, 0.0138? And then take 2.750, which is what it is at 30, minus that 0.0138, and you get 2.7362. Either way you want to do it. Sometimes I'm pretty paranoid. I like to do things one at a time, so I might do it the first way, but the second way is probably a little bit of a shortcut for you. Okay? Let's try another one, see if you really got it. Alright? Find the critical value for a significance level of 10%, 0.10, where the degree of freedom is 64. So again, scan your table on the degree of freedom side, and you'll notice we seem to have 40, 50, 60s on there, but the next one after that's 80, right? So what do we do, right? Well, if I look at the 0.1 significance level, I get 1.296 for 60 and 1.292 for 80. Now notice that's not a huge difference, right? Eventually, by the time we get to z, it'll end up being 1.282, right? So still even not that big of a difference. So how do I figure out how to get to 64? Well, first I need to subtract those two. 1.296 minus 1.292 is 0.004. So basically in 20 degrees of freedom, right, because this is a 20 unit difference, 20 units apart, it decreases by 0.004. So how much does it decrease every one, right, so that I can get to 64? Well, divide it by 20. So take 0.004 divided by 20. And that'll tell you how much to subtract each time. Now you notice your calculator gives you, if you type this in your calculator, it gives you 2e negative 4, which basically means 2 times 10 to the negative 4th power. Okay, basically means move the decimal point 4 places, 0.0002. And why your graphing calculator doesn't just tell you that, I don't know. I didn't design the thing. Okay, but that's how much you're subtracting every 1 degree of freedom. Alright, so I know what 60 is. 60 is 1.296. So I can figure out what 61 is, I can figure out what 62 is, I can figure out what 63 is, and I want 64. Okay? So I literally can just take all of those, right? 1.2958, 1.2956, 1.2954, 1.2952, and that's the one I want. So again, at this point, this would be where you would, potentially draw your graph, and you'd be like, okay, so the t-score is 1.2952, and we'd reject if it was greater than that, right? That's basically what we're doing, all right? And once again, you can use the shortcut. You can figure out there's 4 apart here, so I can take 4 times 0.002, which is 0.0008, and then I can take the original 1.296 minus 0.0008, and guess what? I get 1.2952. Either way you want to do it, whichever way you prefer, it's your choice. All right? It's all up to you now, folks. On your test, there will be at least one question where you have to find a degree of freedom that's not on your table. So you're going to have to do this, okay? And you're going to have to make sure you show this step. One note that you might want to make. If you have to interpolate, you do not have to worry about p-value. Don't worry about p-value. All right? On all the others, you'll have to do p-value, but just make sure on the interpolations, you don't have to worry about p-value. All right? We're not going to put too much emphasis on that. All right, the rest of the period is yours to work on the review. Remember, please be good for the sub. Do what is expected of you. If you have questions, I will be back in the building after school, and I'll be here in the morning right before first period, okay? If you have any questions, just let me know. Have a wonderful day, folks, and I will see you later.